Hello, welcome back. Problem 6-6. So statement is express the internal shear and moment in term of x and then draw the shear and moment diagram. So you can see this figure of problem 6-6. This is beam AB and there is a uniformly increasing load of magnitude W naught that is acting on a length of L by 2. So you have to find the internal shear and moment equation in term of x, and then you have to draw the shear force and bending moment diagram. So let's start with the solution. So first of all, you have to find this reaction forces. If you remove this support, so definitely there will be a reaction force at point A as well as point B. Let this force is AY and this force is BY. Now this is uniformly increasing load W naught, and if you want to convert it into concentrated load, so it will be equal to W naught into this length L by 2, and that is multiplied by 1 over 2. Because this is a triangular load, you can see this is a triangular load, so area is 1 by 2 into W naught into L by 2. So it will be converted into concentrated load, and that will be acting at a distance of, this total length is L and it will be acting at L by this total length is L and it will be acting on the L by 3. Okay, but this length is L by 2, so it will be L by 6. Or you can see that if I remove it, so you can, if I remove it, so you can see this is L by, this distance is L by 2 and it is acting at a distance of L by 2 multiply 1 over 3 L by 2. So it will be equal to L by 6. And this remaining distance will be equal to L minus L by 6, which will give you 5 over 6 L. Okay, now we will apply equilibrium condition in order to find this unknown reaction. So first equilibrium condition is that sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. So from here you can see we are taking sum of all moment about point A is equal to 0. So first moment is due to this load BY and the perpendicular distance is this length L. So I will write it BY into perpendicular distance is L, and as it is producing counterclockwise movement, so it will be positive. The second movement that is produced due to this load, concentrated load, and it is acting this, and perpendicular distance is 6 by L, and it is producing clockwise, so it will be negative. So minus 1 over 2 W naught into L by 2 multiplied by perpendicular distance is 5 by 6 L. Their sum must be equal to 0. So when you calculate it, you will get this BY will be equal to 5 over 24 into W naught into L. So this is your BY. Now we will apply another moment condition said that sum of all moment about point B is equal to 0, or simply you can take the sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So here you can see there are different forces. One is this AY, the other is BY, and the third one is this one which is acting downward, and their sum must be equal to 0. So I will write AY, which is upward, plus BY. BY is 5 over 24 W naught into L minus this concentrated load, which is minus 1 over 2 W naught into L by 2. Their sum must be equal to 0. So when you calculate it, you will get AY comes out to be W naught into L over 24. So this is our reaction force. Now we will move toward shear and moment function. So shear and moment function. So what we will do, we will have two condition, x at L by 2 and this is total length is L. So first we will take for x is greater or equal to 0 and less or equal to L by 2. It means you have to section it somewhere between x is greater than 0 and less or equal to L by 2. So we will draw the shear force diagram, we will section it. So here you will have AY and let this distance where you cut it is X. So definitely there will be a shear force V and there will be a reaction moment M. Okay, as there is no load in this distance, X is greater than 0 and less than L by 2. So we have drawn this section. So again you have to draw the you have to find the this shear force and moment by using equilibrium condition. So first equilibrium condition, that sum of all force along y direction must be equal to 0 and taking upward force as positive. So from here you can see we have two forces, one is AY and other is V. So their sum must be equal to 0. So AY is W naught into L over 24 minus V is downward, so their sum must be equal to 0. And from here you will get this V is equal to W naught into L over 24. So this is the shear force equation. For bending moment, again we will apply sum of all moment. Let this point is J, about J must be equal to 0 and taking the counterclockwise moment as positive. Now here you can see that there is external moment M and moment about point J is due to this AY into perpendicular distance is X. So we will write them. So AY into perpendicular distance is X and it is producing clockwise movement, so it will be negative plus M. Their sum must be equal to 0. So implies that M is equal to AY into X. AY into X and AY is this one. So you will get M is equal to W naught L over 24 into X. So this equation, this is equation 1 and this equation 2 are valid for X is greater or equal to 0 and less or equal to L by 2. Now we will move toward for X is greater than L by 2 and less or equal to L. It means that we will section the beam somewhere here and we will draw the free body diagram as well. So let me draw it. Okay, so this was the beam. Let me draw it somewhere away from this. Okay, so I will draw it over here. So this is your AY, clear. This is your total distance X, and when you cut it, so definitely there will be a shear force V and there will be a reaction moment M. And let this distance is L by 2, clear. And in this portion you have a load which is for length of L by 2, it is W naught, and this length is again this is total X, so it will be equal to X minus L by 2, or you can simply write it as 2 into X minus L divided by 2. It will again give you X minus L by 2. And this load here will be no more W naught, but it will be W naught into this 2x minus L divided by 2, clear, this W naught over the length, and this length was this length, if you take whole length, this is L by 2. Clear? So it will be L by 2. So 2, again 2 will go upward and it will be equal to final, this will be W naught over L into 2x minus L. Now this is uniformly increasing load and it will be acting at this point. So this load, this is a triangular load, so it will be equal to half of W naught is now this one. So W naught into 2x minus L into length, which is equal to this one. You can see this one, into 1 over 2 into 2x minus L. Now what will be the position of this load from this side? So we will talk about this distance. Now this distance will be equal to, you can see this distance is half of 2x minus L. So it will be equal to 1 over 3 times, I will write it, this distance will be equal to 1 over 3 times this value. So 1 over 3 times 1 over 2 into 2x minus L, which will be equal to 1 over 6 times 2x minus L. Okay. Now we will apply equilibrium condition for this. So first equilibrium condition is that sum of all forces along y direction must be equal to 0 and taking the upward force as positive. So you can see there are different forces. One is AY, the other one is this one, and the third one is V. So their sum must be equal to 0. So V is downward, so minus V plus AY is upward, and AY is W naught into L over 24 minus this load. I will show you this load, this load, as this is a point load and acting at this, so their sum must be equal to 0. So minus 1 over 2 into W naught over L into 2x minus L into 1 over 2x minus L. Their sum must be equal to 0. Okay. Over here I have forget one thing, that is here you have W naught over L. This is W naught over L, because this load is W naught over L. Okay. So kindly make this correction. Let's move further. So their sum must be equal to 0. When you calculate or simplify this, you will get V is equal to W naught over 24L into L square minus 6 times 2x minus L whole square. So you have to do this in order to get this V, or you can do it in your own ways, but the answer will be same. Now we will move toward finding the moment sum of all moment about, let this point is O. So about O is equal to 0 and taking the counterclockwise moment as positive. Now moment about this point O is 1 due to this load into perpendicular distance is x. Clear? The second moment is due to this load and perpendicular distance is this one, which is equal to 6 half of 1 over 6 into 2x minus L, and the third moment is external moment M due to reaction. So their sum must be equal to 0. So I will write initial this moment M, which is counterclockwise, minus this moment due to this is again counterclockwise due to this load. So plus the load is 1 over 2 into W naught over L into 2x minus L into distance is 1 over 2 into 2x minus L. Clear? And this perpendicular distance is half of 1 over 6 times 2x minus L. And the moment due to this AY. And this AY into perpendicular distance is x, and it is producing clockwise, so it will be negative. So minus AY. AY is W naught over 24 L. Clear? We will check it. AY is W naught over W naught into L over 24. So what I have to do is that I will write W naught into L over 24. W naught into L over 24 into X. W naught into L over 24. Let me correct it. And perpendicular distance is X. Okay. So okay, so AY, which is 29, 20, W naught L over 24, and perpendicular distance is X. So their sum must be equal to 0. Now when you simplify it, you will get the moment equation, that is W naught over 24 into L square X minus 2X minus L whole cube. So this is your equation. This is your equation number 3, and this is your equation number 4. So equation 3 and 4 are valid for X is greater than L by 2 and less or equal to L. Now we will check, okay, we will check where the shear force will be 0. So we will do it later, on later stage. Okay, now let's move toward the bending moment and shear force diagram. So I have written the equation that we have derived for X is greater or equal to 0 and less or equal to L by 2. So we have shear force is this and bending moment is this. And for X is greater than L by 2 and less or equal to L, we have the shear force is this and bending moment is this. So let's move. For X is equal to 0. For X is equal to 0. So if you put X is equal to, there is no X, so V will be equal to W naught L over 24. So let this one division is W naught into L over 24. Okay. So from A to L by 2 till L by 2. So this is L by 2, which is 0.5 times L. We have this force as constant. Okay. Now at X is equal to at X is greater than L by 2 and less L by 2 and less or equal to L. So if you put L, X is equal to L in this equation, so definitely you will get V at X is equal to L. And using this equation, V is equal to W naught over 24L into L square minus 6 into 2X minus L whole square. So we will get V is equal to minus 5 over 24 W naught into L. So again you can see it is minus 5 times. So again I will go 5 times downwards. So 1, 2, 3, 4, 5. So it will be here. Now in between these two, we will have a shear force equal to 0. So how you can find it? So again we will show you that if you put equation number 3 equal to 0, equation 3 equal to 0, so it means there is no shear force is equal to W naught over 24 L into L square minus 6 into 2X minus L whole square. The product of these two numbers is equal to 0. Since this is not equal to 0, clear, because W naught is not equal to 0, so it means that this L square minus 6 into 2X minus L whole square is equal to 0. And again, if you solve it, you will get x is equal to 0.7041 L. Means at x is equal to 0.741, your shear force will be equal to 0. So we will also draw it. This is 0.5, again 0.67. Let this is 0.7. So this is 7.4. So at this point, you can see this will be 0. Okay. Now this shear force equation is second order, you can see, so it will be parabolic, and since this is toward the negative, so it will be clockwise. So we will, if I draw it, so it will be like this. Again, let me correct it. So this force will be, okay, I am facing some problem, so I will further enhance it, and this will be like this curve type. And at point B, you can see this is minus 5 over 24 W naught into L. So at point B, we have a force of plus 5 over 24 W naught into L. So it will go again upward, and it will become equal to 0. So this is your shear force diagram. Now we will see at this point we have W naught into L over 24 still. At this point we have 0. Okay. Now we will move toward the bending moment. So at bending moment, x is greater or equal to 0 and less or equal to. So if you put x is equal to 0, so at point x is equal to 0, moment will be 0. Okay, at x is equal to 0.5 L. So if you put 0.5 L, so moment at x is equal to 0.5 L. So your moment will be, you have to put it in this equation. So your moment will come out to be 0.0208 W naught L square. Let this values, this is 0.5. So let this value comes out to be here. That this is 0.0208 W naught L square. Okay, at x is equal to, we have at x is equal to 0.701 L. We have shear force is equal to 0, but at this point we will have a maximum bending moment. So what we will do is that you have to put it in this equation. So at x is equal to, I will write at x is equal to 0.704 L. You have moment comes out to be 0.0265 W naught L square. Means slightly greater from this value. So let x 0.7 is here. So let this point is here, somewhat here. Okay. Now at x is equal to L. So if you put x is equal to L in this equation, so you will have moment is equal to 0, because you can see this will be 2L, 2L minus L is L, L cube, and this will be L cube. So L cube minus L cube will be 0. So you will have third point over here, which is 0. Now we will draw, you can see from shear force, so from 0 to L by 0.5 L. It is a constant line of 0 degree. So moment will be first degree higher line, and it will be a straight line. Now from 0 to 0.5 to 0.L, again this is a 1 degree line. You can see this is a 1 degree line, and the slope is decreasing. So the moment equation will be a second degree curve, and it will be in clockwise direction. It will be a curve. And from 0.701 till this L, again this you can see that the shear force is a second degree curve. So moment will be third degree, and the slope will be again downward, so it will be a clockwise. It will be a third degree. Again, I have to ensure that equation is of second degree. So let me check. So yes, you can see the movement will be third degree. So movement will be, if I draw it, so movement curve will be like this. So this is your bending moment diagram, and this point is 0.0265 W naught into L square. This is at a length of 0.5 L, and this is at a length of 0.704 L, and this is length L, is 0.0. So this equation 1 and equation 2 are the shear force and bending moment relation for x is greater than 0 and less or equal to 7/2, and this equation number 3 and 4 is shear force and bending moment equation for length of x is greater than L/2 and less or equal to L, and this is their shear force diagram and their bending moment diagram. This problem is somewhat a little tougher than the rest of other problems, but I hope you have enjoyed this video. And again, if you have any question, you can ask me in comment section. Also subscribe my channel if you are new to my channel. Thank you for watching.